Hello learners, this is Education Online program. Our subject is chemistry and I'm teacher Lily. I'm going to teach the chemical properties of group 2 elements, and here we are going to show the reaction of calcium and magnesium with water. The reaction of calcium and magnesium with water. So here we are going to see that the reactivity of group 2 elements, they usually increases if we move down the group. So calcium metal, which is the third element in group 2 elements, it is when it remains at the bottom of the beaker. When you throw it or when you put it inside a water or a container containing water, it will remain at the bottom of the beaker. So this is showing that calcium is much denser than water, so it goes down because it is much denser than water. So a stream of colorless gas displays the water inside the boiling tube. So in this case, we increase the reaction by boiling the water. So the gas collected produce a pop and sound when a burning spleen is introduced into the mouth of the tube. So in this case, when you have the reaction of calcium with water, it produces hydrogen gas, and a hydrogen gas test is it produces a pop sound when you bring a spleen or glowing spleen and inside or out nearer to the wall of the test tube or at the top of the test tube, and it will give us a pop sound. And this is representing that when you react calcium with the water, it will give us hydrogen gas, and this sound is the sound that represent or show that there is hydrogen gas present in that reaction. So we are going to see that the gas collected produce a pop sound, and this is hydrogen gas, confirming it as hydrogen gas. So the resulting calcium hydroxide solution turn red litmus paper to blue, showing it is an alkaline solution. So learners, we need to remember that with the reaction of group 2 elements with the water, any other group 2 elements with the water, it produces hydroxide solution, and also it produces hydrogen gas. So each of them will have a significant way of identification. So in this case, we are going to see that the alkaline solution of calcium hydroxide or magnesium hydroxide, they will turn the red litmus paper into blue. And the hydrogen gas is tested by bringing a glowing spleen, and you put it in near to the mouth of the test tube, and it will produce a pop sound which show that there is a hydrogen gas present in that product. So here we're going to represent this by writing a chemical equation which show that calcium which is a solid plus water, it will give us calcium hydroxide and plus hydrogen gas being evolved. So here we have aqueous solution, here we have a gas, here we have liquid, and here we have a solid. So here we are going to show that the hydrogen gas produces a pop sound. So we show that this is hydrogen gas present in the solution. So this here will show that when you put a deep red litmus paper, so red litmus paper will turn to blue. So red litmus paper will turn to blue. So this is a test for alkaline solution, and also this is a test for identifying the gas hydrogen. So here we are going to see that the reaction of magnesium with water is slow. When water was heated to boiling point, the reaction proceeds much faster. So for the second element, which is magnesium, so magnesium reacting with the water, when if it is cold water, the reaction is slow or very slow. So when you heat the water to boiling point, it will increase the reaction of magnesium with water to form the alkaline solution of magnesium hydroxide and produces hydrogen gas as the gas present in the byproducts. So we shall have magnesium, which is a solid, plus water, which is represented by a liquid, and it will give us magnesium hydroxide. So magnesium hydroxide plus hydrogen gas. So here this is represented by a gas, here by an aqueous solution. So hydrogen is liquid and solid is magnesium metal. So the same thing, when you dip red litmus paper into the solution of magnesium hydroxide, it will turn the red litmus paper to blue. The same thing here, when you put a glowing display near to the top of the test tube that contains hydrogen gas, it will produce the pop sound, which show that there is hydrogen gas being evolved in the reactions. So you're going to see that as you have not boiled the water, then the reaction of magnesium with the water will not proceed. But as you increase, as you boil the water into the boiling point, the highest boiling point, then magnesium will react very fast with what? With water. So we need to remember also that the products formed are hydrogen gas and an alkaline solution of hydroxide of either magnesium, calcium, or any other group 2 elements. So all this, however, is showing us that the reaction from magnesium to the last element, we are going to say that the reactivity with the water increases as we move down the group, because here, as you see that in calcium, the water is not boiled, but even though the water is cold, it still has a fast reaction compared to magnesium. But for magnesium, it has the water has to be boiled in order to increase the reaction with the water to form the alkaline solution and hydrogen gas. So here we are going to see that a white suspension forms in the beaker as the reaction progresses. It means we are going to have a white precipitate. So this magnesium hydroxide will show like a white precipitate, but it is not a precipitate as such, but it is a solution, but it has a white color. So also we are going to see that as the reaction progresses, we are going to see that the resulting solution is magnesium hydroxide, which turn the red litmus paper into blue. So first of all, we need to remember that as we have the reaction of water with the magnesium, it will give us magnesium oxide and a hydrogen gas. The same thing when you have an excess steam water or an excess boiled water, it will react with the magnesium to give us hydroxide, magnesium hydroxide. So in this case, we need to remember that the reaction of magnesium with the water, first of all, will give us magnesium oxide. But when you add more steam or more hot water, it will have, or when you increase if you increase the boiling of the water by adding more water and then you increase the boiling, you will have magnesium hydroxide form. So the first reaction here will give us magnesium hydroxide when this is in excess. So we have excess or more steam. Actually, this water, we consider it as a steam of water. So when you have a reaction, when the water is not excess or not more, we are going to have magnesium oxide plus hydrogen gas. So magnesium oxide represents a solid, and for the first reaction, which is in the presence of excess water or excess hot water, we are going to have magnesium hydroxide and then hydrogen gas. So for the second reaction, whereby you have a fewer water, it will give us magnesium oxide and then hydrogen gas. So you will not get confused when you have these products being formed. So if you have magnesium hydroxide, it means that the steam is more, and when you have magnesium oxide form, it means the steam or the water which is hot is a bit few. So that is why it gives you this magnesium oxide and hydrogen gas production. So you're going to have the reaction of magnesium and calcium with chlorine gas. So calcium appears to burn less vigorously in chlorine to form a white solid of calcium chloride. So you are going to see that the reaction, although it is supposed to be, the reaction has to increase from top to the bottom, and we know that calcium follows magnesium, so it means it has to react so fast compared to magnesium. But we need to remember the coating that has been caused at the walls of the metal. So this will cause a slowing in the reactions. So we are going to have the reaction of calcium reaction of magnesium and calcium with chlorine, and here we are going to see that the reaction with magnesium of chlorine with the magnesium is not vigorous, or the reaction with appears to burn less vigorously. So it means the reaction is not so speedy or is not faster. So that is why it is considered to be less vigorous with the chlorine to form calcium chloride. So the reaction is represented by calcium plus chlorine gas. It will give us calcium chloride, and here this is considered to be a solid. So calcium chloride is a solid, and it is represented when we say that the calcium plus chlorine, it is going to give us calcium chloride, and this reaction is less vigorous. So the reaction is less vigorous. So we're going to see that the reaction is less vigorous. Why? Because there is a coating at the surface of calcium, and this makes the reaction to be slower with the chlorine gas. So magnesium burns in chlorine with a bright light to form a white solid of magnesium chloride. So remember that this calcium chloride is a white solid. So calcium chloride is a white solid. Calcium chloride is a white solid, and here we are going to see that the reaction is less vigorous. It means as we form also as the reaction of chlorine with the magnesium, it will give us magnesium chloride, and this is also showing that this reaction is giving us a white solid of magnesium chloride. So here we are going to see that magnesium burns in the presence of chlorine. Magnesium burns in chlorine. Magnesium burns in chlorine, and it will give us with a bright light to form a white solid of magnesium chloride. A white solid of magnesium chloride. A white solid of magnesium chloride. So we are going to see that magnesium burns in chlorine with bright light to form white solid of magnesium chloride. So to represent this reaction, we are going to see that magnesium, which is a metal, and it is represented by S to show that this is in solid form. So plus chlorine gas, it will give us magnesium chloride. And here magnesium chloride is a white solid. It means we are going to represent it by S, a small letter S, to show that this is a solid being formed. So this white solid is formed as you expose magnesium to burn with chlorine, and this gives us a bright color, and this bright light to show that this is a reaction of magnesium with chlorine and to form a white solid of magnesium chloride. So in order for magnesium to form a white solid, a white solid of magnesium chloride, you have to expose it to chlorine, or you burn it with chlorine, and then it will give us a white solid of magnesium chloride. So the activity of group 2 elements with the chlorine increases as you go down the group. So reactivity, you need to remember that all the reactivities, they increases. Reactivity with the chlorine increases down the group. It increases as you move down the group. It means beryllium will have a lower reactivity with the chlorine, and then calcium will have a higher reactivity with the chlorine. Or in other way, we can say that the reactivity is more faster with the calcium compared to the upper elements, which is beryllium or magnesium. So the reactivity with the chlorine increases as we move down group 2 elements. So we are going to see that the reactivity increases as you move down the group. So magnesium is more reactive than calcium, but this is not true, because calcium is more reactive, only that a coat of calcium chloride form very fast, such that the inner slippery calcium metal cannot be easily reacted by chlorine. So if you remember that I was saying that these metals, they have the ability of forming a coating outside the metal. So this is caused by the presence of the air, and it is formed at the surface of the metal, which prevent the reactivity to be faster. So any reactivity with any other reagent will not be faster as compared to what we are saying, that the reactivity should increase as we move down the group. So we shall see that here the reaction of calcium with the chlorine is less vigorous, while the reaction of magnesium with the chlorine is a bit faster compared to the one of calcium, which is not true, because calcium actually should have a higher reactivity compared to the one of magnesium, and this make magnesium to have a higher reactivity compared to the one of calcium. So in this case, we are going to say that the reactivity increases as you move down the group. Remember, here we have reaction of calcium with and magnesium with water. So when you have the reactivity here also, it increases as you move down the group. We are going to see that with the water, because it has to dissolve the metal, or you throw the metal inside the water, and then it will start what? The reaction. That is why it has been shown here that magnesium, because it is less reactive compared to the rest of the element below in the group, it will have to form magnesium oxide when you have a less steam water or the water, when the water is a bit cold, you will have the reaction to be very slow and it will give us magnesium oxide. But when you boil the water and you increase the amount of water, it will give us magnesium hydroxide. So here, learners, we need to remember that with the calcium hydroxide or magnesium hydroxide, they turn the red litmus paper to blue. So it means the test for calcium hydroxide or the alkaline solution of the reaction between magnesium or one of the group 2 elements with the water, it has to show that the red litmus paper should turn to blue. And also the hydrogen gas should give us an identification test, which is giving us a pop sound when you put a glowing spring near to the mouth of the test tube, and when it is exposed to the oxygen, to the hydrogen gas, it will give us a pop sound. So learners, we have known the reaction of calcium and magnesium with the water, the reaction of calcium and magnesium with the chlorine. Also previously we have known that the reaction of calcium and magnesium with oxygen, which is representing the rest of the elements. So by this time we have you will know what is happening when you have a reaction of group 2 with the chlorine, a group 2 with water, a group 2 with oxygen, and you will be in place to answer them clearly with a very clear chemical equation. So with these learners, we have come to the end of this lesson. So thank you very much for listening till we meet next time.